All right. So we are going to learn about different properties of exponents. So before we learn about the properties of exponents, let's review what an exponent is. So when we have this little number that's up above, we call that an exponent, right? So this is my exponent. And then the number at the bottom down here. So here are x, this is our base. So we would say x is our base and it is our exponent is b, or it is raised to the b power, right? We're going to see how, learn some different properties to help us simplify expressions with exponents, okay? So we're going to start with the easiest one. It's the property of multiplication. So we have an example here. I have 3 to the 4th power times 3 to the 2nd power, okay? Exponents just mean repeated multiplication. So if I break this down, 3 to the 4th power really means 3 times 3 times 3 times 3. Okay. 3 to the 2nd power means 3 times 3. And I'm multiplying these two together. So I have 3 times 3 times 3 times 3 times 3 times 3. Since I only have all multiplication and it's all the same number, I can combine these and I just count how many threes do I have. Well, I have 4 on this side and I have 2 on this side. So in total, I have 6 threes. So I can represent that as being equal to 3 to the 6th power. Okay, so really all we're doing, if we're multiplying them, so let's write our rule in words. So the first thing we have to know is that these rules only work if we have the same base. We have the same base. Okay, notice our base was 3, right? If we have the same base, what we're doing when we multiply them, we're really adding the exponents. And something to remember all throughout this that you'll see over and over again is the base stays the same. So our base is never going to change, right? All we're doing is simplifying the exponent part of it. So in the middle, we have our expression. In math, we do a generalizing. So this is our general rule. So if I have the same base, so here it's a, I have a to the m times a to the n. And when we simplify it, my base stays the same. And I'm adding those two exponents. So m plus n. Okay, so that is our first exponent property of multiplication. We just add the exponents. So here's a few practice problems. Go ahead and try those. See if you can get the hang of that property. All right, our next property is nested exponents. Really what that means is when we have multiple exponents, so 2 or more exponents. Okay, so we can take something raised to a power and raise it to another power. So when we look at our example here, I have 5 raised to the 6th power, okay? And now I'm raising it to the 2nd power. So I have 2 exponents in this problem. The parentheses right there, these parentheses show me that I'm taking this whole thing, so 5 to the 6th power, and then raising it to the 2nd power. So again, let's kind of break this down to see how this property works. We know what exponents mean. They mean multiplication. So if I'm taking 5 to the 6th, raising it to the 2nd power, that means I'm multiplying it by itself twice, right? 5 to the 6th times 5 to the 6th. Okay. Oops. Well, we can use the property we just learned. We know when we multiply, we keep the base the same and we add the exponents. So we get 5 to the 12th. Okay. The cool thing we're going to learn is there's a shortcut. So if you notice my 2 exponents, I have 6 and 2. So how can I go from 6 and 2 straight to 12? Well, we just multiply them together. 6 times 2. Right? So that gives us a little shortcut. So now when we look at our expression, I have base A. So my base is going to stay the same. And my exponents are n and m. So I'm going to multiply those two together because I have a to the n raised to the m power. Okay. So writing it out in words, again, if we don't really have to worry about if we have the same base, right? Because there's only going to be one base. If we have our multiple exponents, we multiply the exponents, right? And again, every time, this is a big thing to remember, what happens to our base? Base stays the same. Okay. So again, you have a few practice problems. Go ahead and try that property of nested exponents. Pause the video. All right. We got quite a few properties. Our next one, what happens if we have different bases? Okay, so we can have things where we have more than one or we have different bases. So we're going to look at two examples if we're multiplying or if we're dividing. So let's start with the multiplication. Well, I have 2 to the 4th power times 8 to the 3rd power, and I'm taking all of that and raising it to the 5th power, right? So the thing to remember about exponents is if the bases are different, we can't use those properties we learned before, right? But what we can do is if we think about writing this all out, I'm going to take 2 to the 4th power, and it's going to be written 5 times. So I can use that multiplication property that we learned and multiply these two exponents together, which is going to give me 2 to the 20th power. And I'm going to multiply that. And then 8 to the 3rd power is going to be written 5 times as well. So again, I can multiply those exponents and get 8 to the 15th power. Okay, so keeping our bases separate, I have 2 to the 20th times 8 to the 15th. Right, and we can see that in our expression here. If I have a times b raised to the m power, what happens is that m exponent goes to both of my bases, but I have to keep my bases separate. Okay. So we can kind of think of this is really similar to our distribution, right? So we're almost going to distribute. It's not technically the distribution property, but it acts similar, whereas we're multiplying. So we're going to distribute, we're multiplying the exponents, right? Using that multiplication rule, the nested exponents rule, and we're going to keep the bases the same. So we're going to write keep bases same and separate. Okay. All right, what happens if we have it in a fraction? So if we're dividing, right? So again, let's show why this rule works. Well, I have 3 over 4 to the 7th power, right? So that means I'm going to have 3 over 4 times 3 over 4 times 3 over 4, right? 7 times. Keep going. 1, 2, 3, 4, 5, 6, 7. Oh, it's a lot. So if I multiply these fractions together, if we remember how multiplying fractions together, I multiply all the numerators together, which would be 3 times 3 times 3 times 3 times 3 times 3 times 3. So I have 3 times itself 7 times. So we know we can write that as 3 to the 7th. And same, then we multiply the denominators. So 4 times 4 times 4 times 4 times 4 times 4 times 4, which gives me 4 to the 7th power. So we can write that more simplified as 3 to the 7th over 4 to the 7th. So that means when we have any fraction that exponent is going to go to the numerator and the denominator. So if I have a over b raised to the m power, what I'm going to get is a to the m over b to the m. Okay. So putting that in words, we're going to say we multiply the exponent or distribute the exponent. Multiply the exponent to the top of our fraction, which if we use our vocabulary, that is our numerator. And the bottom of our fraction, which vocabulary, that is the denominator. Okay, so that exponent goes to the top and the bottom. All right, so again, pause the video, try these 4 practice problems. All right, few more properties left. Now what happens if we're just straight dividing? So what happens if we're dividing, but we have the same base? Okay, so let's look at our example. I have 3 to the 4th power divided by 3 squared, or 3 to the 2nd power. So that's 4 3s on top and 2 3s on bottom. Well, the cool thing with fractions is if we have the same number on the top and bottom when we're multiplying, we can cancel them out because dividing, they make 1. So this 3 cancels out that 3. Those 2 3s cancel out. And all I'm left with is 2 3s on top, which we know how to write 3 times 3. That's just going to be 3 squared. Okay. So if you notice, what is our shortcut? Well, we had 4 on top and 2 on the bottom. So when we cancel them out, what we're doing is we're just subtracting them. Okay, so if we have the same base, we're just going to subtract our exponent. So a to the m over a to the n is going to be a to the m minus n. So the base stays the same, and we just subtract our exponent. So if we have the same base, here we subtract our exponents, right? And it kind of makes sense because if we think about it, when we multiplied, we added them. So now we're doing the opposite and dividing, and we do the opposite of that and subtract, right? And as always, our base stays the same. Never change your bases. All we're trying to do is simplify it. We're not changing the base. Okay. So there's some practice problems. So you can try your division property, pause the video. Okay, coming back, we're on our last page. We have a few more. All right, the 0 exponent property. This one's great. I love it because it is the easiest thing ever. Anything to the 0 power just equals 1. Anything to 0 power equals 1. Doesn't matter how big the number, how small the number, if it's a decimal, a fraction, an like positive, negative, whatever, anything to the 0 power equals 1. So whatever the base is, it just turns it to 1. So that one's a really easy property. So go ahead and do those 8 practice problems really quick. Okay. We are on our last property here, our negative exponent property. This one's probably the hardest because it takes a little bit of thinking on our part. So what does a negative exponent mean, right? Well, we know a positive exponent is repeated multiplication. So a negative exponent represents repeated division. Huh? Yeah. So it represents repeated division. So we think about the exponent. We think about, we have our base here is 4. This negative tells me I'm going to divide, and the 2 tells me how many times I'm going to divide, right? So I'm dividing by 4 twice. So we can think about this as a fraction, right? So I'm taking 1 and I'm dividing it by 4 times 4, or I'm dividing it by 4 2 times. Well, we know how to represent 4 times 4. That is just 4 squared. So that becomes 1 over 4 squared, right? So a somewhat of a tricky thing. So in our expression, one way to think about it is whatever your base is, we're going to turn that into a fraction. So if I have a to the negative 1, I'm going to put that over 1, right? Then what we're going to do is we're going to flip, we're going to take our base and we're going to move the base either to the top or the bottom, because when we're dividing, we flip. So this becomes 1 over a, and then that exponent becomes positive. Okay, because we're thinking about, oh, we're dividing by that number. So a to the negative 1 means I'm going to divide by a 1 time. Okay. This also comes up, you can have negative exponents in the denominator of a fraction, right? So let's say I have like b over a to the negative 1, right? What's going to happen is that a is going to go from the bottom of my fraction to the top. So if I'm dividing by divided a, dividing, they double, so it becomes the opposite, and I end up multiplying by a to the first power. So that exponent goes from the bottom to the top, and then we multiply. And whenever we don't have a number in that part of our fraction, so now that the a to the negative 1 went to the top, there was nothing left on that bottom of our fraction. So we use 1 as a placeholder for our fractions, right? Same thing here. When that a went to the bottom of our fraction, we put a 1 on the top. That 1 represents, because when we're moving it, we're really dividing. So when we're dividing by itself, we just have that 1 as a placeholder. So this is probably the trickiest rule. Once you get the hang of it, it's not too bad. But here's what's going to happen. We're going to move our base. So if it's in the top of our fraction, we're going to move it to the bottom. If it's on the bottom of the fraction, we're going to move it to the top, right? Because dividing means it's going to go to the opposite spot. And then all we're going to do is keep the base the same, and we're going to make our exponent positive. So think of that negative as telling you, hey, this is going to be the opposite. So if it's on the top, put it on the bottom. If it's on the bottom, put it on the top. Once you do that, the negative goes away and you just have a positive exponent left over. Okay. So some final practice problems for this rule. And then the last 4 on here, we're going to combine a couple of our rules together. So we see these a lot in problems. We combine our exponent properties. Sometimes we have to use multiple ones to simplify a problem. So go ahead and try those practice problems. Once you've got the hang of all your different properties, you have a nice mixed review where you're going to combine different exponent properties and things together so that we can practice all of our different properties at once. Okay. So hopefully this was helpful and you learned about your exponent properties. Do all your practice problems and good luck. You're earning.